In this video, we're going to look at series. And they're very similar to sequences, just a slight difference. So if we look at sequences, there's really two types of sequences. We have a finite sequence, which just means you have a set number of terms. In this finite sequence, I have 5 terms. An infinite sequence has this dot, dot, dot on the end. Doesn't look like a big difference. But that just means it keeps going and going and going. So once you know what type, or you know it's geometric, arithmetic, or however else you find the next term, in an infinite sequence, it just keeps going and going and going. So the difference between a sequence and a series is that. Should have both at the same time. So when we have a series, all we're doing is we are adding all the terms of the sequence. So we're summing up a sequence. Now, we can have a finite series where we add these 5 terms, or we can have a infinite series where we add up an infinite number of terms. So, the way it looks right now is 0, 3, 6, 9, 12. When we add those up, this is called expanded form. So you can see all our terms, they are just added together. If we want to evaluate the series, then we want to add up all those terms. So as we look at these, sometimes we will be asked to expand the series. That just means write it out. Now, if it's infinite, you can't write out all the terms. We write out 4 of them, put dot, dot, dot. If it says evaluate, then we want to add them up. Now, how do we add them up? Well, if we have a arithmetic series, we're going to have this formula. S sub n, which this means the sum of the first n terms. So S sub n is the sum of the first n terms. And here's our formula. N times t sub 1 plus t sub n over 2. And this t sub n formula, let me just point out, is our formula that we've already done for arithmetic. So what we did before, we need to use that same formula. So let's find the sum of the first 20 terms. So if we look at our formula, our n is 20, our first term is 4, we divide by 2, plus, now I need to find my nth term, or my 20th term. So let me come up here and say my 20th term is 4 plus 20 minus 1 times 3, which is 4 plus 19 times 3. And I get a 61. So I put a 61 here. So I have 20 times 4 plus 61. Divide by 2. And my answer is 650. So this formula works when you have an arithmetic series, which is like an arithmetic sequence, when you add the same thing every time to get the next term. If we have a geometric series, we have a little different formula. We have our t sub 1, that's our first term, and we have r. Notice it doesn't ask for the nth term. So if we want to find the sum of the first 30 terms, we have 1/2, 1 minus 1/2 to the 30th, all over 1 minus 1/2. Now, the biggest problem people have here is putting stuff in the calculator. because of the parentheses and the fractions. It really messes people up. I would encourage you to check here, and you get 9, 9, 9, 9, 9, 9. And on my calculator, I have pretty much they're all 9s, and then the last one, however many 9s that is, I got a 1 on the calculator. So you can check and see if you typed that in correctly. But that is one of the biggest problems with geometric series, because of these. Many times our R is a fraction, so you get these kind of large fractions to an exponent. If your R is a bigger number, a 2 or a 3, then the sum of the first 30 terms is a gigantic number, then you can start getting with scientific notation. So you just got to be careful with geometric when you do that in your calculator. Now, let's say we're given a formula, a little bit different kind of a problem. We're given the formula. S sub n is 3n plus 4. So just like our terms of our sequence, now these are our kind of our terms of a series, so to speak. S sub 1 would just be like before, that'd be 7. S sub 2 would be 10. 3 would be 13. 4 would be 16. So that's just like we did before, plugging n in. Here, this is just 3 times 2 plus 4. Now, if I know those first 4 terms of the series, can I determine my actual terms? These are the sums. This is the sum of the first term. This is the sum of the first 2 terms, and so forth. So this is the sum of just the first term. So that tells me the first term has to be 7. This one is the sum, S sub 2, of the first plus the second. Well, if the first was 7, and the sum of the first and the second is 10, then my second needs to be 3. This is the sum of the first, the second, and the third. So 7, 3 is 10 to get 13. My next term is 3. And then once again, I'd get 3. So this is how I could go. By knowing the sum of the terms, I'm able to figure out the actual terms of the series. So I'd have the series 7 plus 3 plus 3 plus 3 plus, we'll say this is infinite, dot, dot, dot. And I want to know what is S sub 4? 16. Now, let me say one thing going back here for a second. We're dealing with finite series. And if it's not arithmetic, and we have this formula, if it's not geometric, and we have this formula, there's really no formula to calculate the sum. If it's a neither, the only way to do it is actually add up all the terms. There's no formula for it if it's not arithmetic or geometric. Our next video, we're going to look at what do you do if it's an infinite, which at first seems kind of odd. How can you add up an infinite number of numbers? Well, you notice in this case, 1/2 plus 1/4 plus 1/8 plus 1/16, that equals 1. You're adding up an infinite number of numbers, and you get 1. So we want to look at how that works in our next video. And you can kind of see it here. Notice if I add up the first 30 terms, I get 0.9999999 and 1. So as I add up more and more and more terms, I get closer and closer and closer to 1. All right, homework on series.